Hey everybody, hope that you're doing well and that you had a great spring break. Today we're going to be starting our next unit, which is solids. So I put a link to the new packet on your agenda and assignments document. So I would suggest, if it's an option for you to be able to print, that I would print out the packet and then just treat it like we would in class. If you don't have a printer or for some reason are unable to print the packet, then I would suggest just using notebook paper to take your notes and do your examples. And you're welcome to also do all of your practice work on notebook paper and just take pictures of that to submit it. So we are starting a unit called solids. So solids are three-dimensional shapes. So things like boxes and spheres and cylinders. This is stuff that I think you learned about a little bit maybe in middle school. So some of this might look a little bit familiar. And we're specifically going to be talking about two things with solids. We're going to be talking about surface area and volume. So if you look at page 2 of your packet, page 2 has a lot of important formulas on it. And if you look at this page by itself, I feel like it might seem a little bit overwhelming. But basically what we're going to be doing in this unit is going through each of these formulas separately and talking about what all of these things mean. So this page is just kind of like one place where everything is. So it's kind of like your cheat sheet page. But we are going to be going through these one by one as we work our way through the packet. One thing that I want to reiterate and point out from the beginning, you do not have to memorize any of these formulas. Even if we weren't doing this via distance learning, I still would have given you a formula sheet. I would have given you this sheet as your formula sheet. So please don't feel like you have to memorize these. Know that you can always come back here and look them up. What we're going to be doing is just kind of talking about how to use the formulas and what everything stands for so that you understand how to plug into them. So you can see on this page all the different types of solids that we're going to be talking about: prisms, cylinders, pyramids, cones, and spheres. Okay, so the first type of solid that we're going to talk about is prisms. So a prism is a three-dimensional figure that has two parallel congruent bases. So think about what that means. So it's two shapes that are exactly the same size. That's the congruent part. And they're parallel. So that means that there's the same distance between them at every point. And those two shapes are joined by other sides of the prism, which we call faces, that are all going to be rectangles. So for example, if you think about the base of a dumbbell, so it has this kind of head on it, the head of a dumbbell. So the bottom of it is a hexagon. This has 6 sides. So when we look at it from this side, so the bottom and the top of this piece are both hexagons. Those are the parallel congruent bases. And then they're connected by these rectangles. So these are called the lateral faces of the prism. So this shape right here, this head of the dumbbell, is a prism. Specifically, it's a hexagonal prism. So prisms are always named by the shape of their bases. Okay, so if you look at the two that are in the notes, so the one on the left, the two shapes that are parallel to each other are the pentagons. So the pentagons are the bases of this prism. And then those pentagons are connected by 5 rectangles. The one on the left, so this would be a triangular prism. So one thing that you have to be a little bit careful about with prisms, when we see or hear the word base, that makes us think of the bottom, but the base of the prism is determined by the two shapes, the two sides that are parallel to each other. So when you look at this triangular prism, it looks like it's sitting on that rectangle, but the rectangle isn't the parallel shape. The parallel shapes here are the triangles. The rectangles are connecting the triangles. So the bases of this would actually be considered those two triangles. And then this would be considered a triangular prism. So when we talk about prisms and all solids, really, we're going to be focusing on two special characteristics of them: their surface area and their volume. So the surface area is simply the area of the entire surface of the prism. So if we found the area of all of the sides of the shape and added those together, including the bases, that gives us the surface area. So, easy example. This is a box of cake mix. So the surface area of this box is just the sum of the area of all 6 of its sides. So when we're talking about prisms, we're going to focus on triangular and rectangular prisms. So the surface area formulas, they look a little bit overwhelming, but literally all that the formula is doing is adding up the area of all of the sides of the shape. So in a triangular prism, your 2 triangles are congruent. So if you find the area of one of them, that's going to be the same as the area of the other one. So that's why this formula has that 2b in it. B is the area of the triangular base. And since those are the same, you can just find it one time and multiply it by 2. And then the L1, L2, and L3 here, those are the areas of the 3 rectangles that make up the sides of the triangular prism. And those are all going to be different, so you would just have to find all of those separately. In a rectangular prism, we have a little bit of a shortcut. A rectangular prism is just a fancy word for a box. And a rectangular prism, there's 3 pairs of congruent sides. So again, thinking about my box of cake mix, the bottom and the top of this box are congruent. The left and right sides are congruent, and the front and the back are congruent. So with rectangular prisms, we have a little bit of a shortcut in that we can just find the area of 3 of the rectangles and multiply each of those by 2 because those rectangles come in pairs. So to find the surface area of a rectangular prism, we would find the surface area of the bottom, or the area of the bottom, that's length times width, multiply that by 2. We would find the area of the left and right sides, so just find one area, multiply by 2, and then find the area of the front and multiply by 2, and that would also give us the back. So you have a little bit of a shortcut with a rectangular prism. And with cubes, you have even more of a shortcut. So in a cube, all 6 sides are exactly the same. And even more than that, all of the edges are exactly the same. So in this cube, or in any cube, you just have to find the area of one side and multiply that by 6. So in this cube, in a cube, again, all of the sides are going to be the same. So the area of that base would be x squared. And then because all 6 sides of the cube are the same, we would just multiply that by 6. So cubes are the easiest thing to find the surface area of because all 6 of its surfaces are exactly the same size. All right, so let's look at an example of a triangular and rectangular prism here. So you have these formulas. Honestly, when you have a picture, I think it's even easier to just kind of, from your picture, find the area of all of the different sides that make up your shape. So looking at number 1, to find the surface area of this triangular prism. So I'm going to start by finding the area of the triangular base. So this is why I had you watch that little short review of area formulas. So the area of that triangular base is going to be 1/2, and then area of a triangle is 1/2 base times height. So 1/2 24 times 7, and that's 84. So the area of that triangle is 84. That means then that the area of the other triangular base is also 84 because those bases are always going to be congruent. But now we have to find the 3 rectangles, and those are all going to be different. So we just have to find each of those areas separately. So I'm going to start with the area of the bottom rectangle. So area of a rectangle is just length times width. So that's going to be 24. And then this distance here is going to be the same as this up here. So that's 28. So 24 times 28 gives us 672. Then I'm going to find the area of this back rectangle. Its dimensions are 7 by 28. So 7 times 28 would give us 196. And then finally, I'm going to find the area of this rectangle that's on the slant, and its dimensions are 25 by 28. So it would have an area of 700. And so then to find the surface area, we just have to add up all 5 of those individual areas. So 84 plus 672 plus 700 plus 84 plus 196 gives us a total surface area of 1,736 units squared. So surface area definitely takes the most work, especially surface area of prisms, because you just have to find the areas of all of the pieces of the shape. All right, so the second example here is a rectangular prism. So we have a little bit of a shortcut here. This has 6 sides to it, but those 6 sides happen in 3 pairs. So we only have to find the area of 3 rectangles and just multiply each of those by 2. So I'm going to start here. This front rectangle, 4 times 10, has an area of 40, and that's going to be the same area as the back of the rectangular prism. So my total area is going to be 2 times 40. Now I'm going to find the area of this right side. So it still has a height of 4, and its length right here is going to be 17, same as this length right here. So 4 times 17 gives us 68. And that side is the same as the left side of the box over here. So that's also going to get multiplied by 2. And then finally, we need to find the area of the top and bottom of the box. So the top of the box, it has dimensions 17 by, this would also be 10. 17 times 10 is 170. And multiply that by 2 because that's also going to be the area of the bottom of the box. And if we add all of those up, we end up with 556 units squared. Oh, sorry, this one has centimeters on it. So we don't have to use the generic. So centimeters squared. So we're just finding the area of all of the pieces of the rectangular prism and adding them together. So for a triangular prism, the only thing that's going to be the same is your 2 triangles. So when you find one triangle, you can multiply that by 2 or just copy that to your other triangular base. But then the 3 rectangular sides are all going to be different. And a rectangular prism, your front and back are going to be the same, your top and bottom are going to be the same, and your left and right are going to be the same. So you only have to find 3 actual areas and just multiply each of them by 2 to find your surface area. All right, so you'll notice actually in this entire unit, there's not a ton of examples in your notes because honestly, all of these problems are pretty much exactly the same. You're using the exact same formula every time you find the surface area of a triangular prism, every time you find the surface area of a rectangular prism. It's just new numbers and new dimensions. So the last part of this is to talk about the volume of these solids. So volume is how much space a shape occupies. So thinking back to my box of cake mix. Remember that surface area was the amount of cardboard it takes to create the outside of the box. So it's the area of all of this cardboard. Volume is how much space is actually inside the box. So if we were completely filling this up with cake mix, the volume would tell us how much cake mix could fit inside the box. And our notation for volume is always going to be in cubic units. So whatever your unit is, you're always going to cube it to find your volume. So the formula for volume, I think, is actually a lot simpler because it's much more generic. The volume of any prism is the area of its base. And remember that when we're talking about the base of a prism, the base is always going to be one of those two congruent and parallel sides. So to find the volume of a prism, we're going to find the area of one of those bases, and then we're going to multiply that by the height of the prism. Now, this is something that's a little bit tricky. The height of the prism is defined to be the distance between the bases. So a lot of times prisms are actually sitting on their sides, and so the height it doesn't look like a height. Typically, we think of height as being vertical, but a lot of times the height is actually going to be more of a horizontal dimension when we're talking about prisms, because the bases could be on the left and the right instead of necessarily being on the top and the bottom. So if you look at these two pictures, specifically the triangular prism, the bases there are the triangles. So the height there is the distance between the two triangles. All right, so let's finish these notes up by looking at these last two examples. So finding the volume of this rectangular prism and then a triangular prism. So again, the formula here is very generic. Our formula for the volume of a rectangular prism is the area of the base times the height of the whole prism. So this prism happens to actually be sitting on its base. So the area of the base is going to be 5 times 4. And then we're going to multiply that by the height of the prism, which is 3. And 5 times 4 times 3 is 60. We don't really have a unit here, so we're just going to say units cubed would be the volume of this prism. All right, so the last one, the triangular prism here. So again, we're starting with that generic formula, area of the base times the height of the prism. So the base here is the triangle. So we need to find the area of this triangle, and then we're going to multiply that by the distance to the other triangle, which is 7. So that's 7 right there. That's the height of the prism. So to find the area of that triangular base, remember that area of a triangle is 1/2 base times height. Don't get that height confused with the height of the prism. So the area of this triangle is 1/2. Its base is 4. And the height of this triangle is 3. So the area of that triangle is 6. And then we're going to multiply that by the 7, which is the height of the whole prism, the distance from one triangle base to the other. And so this would be 42 feet cubed would be our volume there. Okay, so to find the volume of a prism, you find the area of the base, and then you multiply that by the distance to the other base. And remember that the base is the two parallel congruent sides. So it's not necessarily the bottom of your shape. That's just something that you have to be careful about when you're looking at your pictures. All right, so those are your notes for prisms. You're going to do some practice now on volume and surface area. So you're just using the formulas that we applied. Make sure that you read carefully for which one that you're supposed to find. And I will see you in the next video for cylinders. All right, see you guys soon.